My name is Tom Nance. I work for Starburst Data here in New Hampshire. I'm Director of Customer Solutions, been here about 4 years, been in data warehousing for about 25 years and data lakes and all that good stuff. So excited to present to you. Go ahead, Andrew.
Yeah, I'm Andrew Brust, and among other things, I lead the data and analytics work that we do at GigaOM, research-wise. I've been in the data world really since the 1980s. I'm also a journalist in the field, writing for the New Stack and sometimes for VentureBeat. And I'm full of opinions. And once upon a time, I was a developer. So maybe call me a frustrated developer now.
Okay, so for the agenda, got 5 different things that we're going to talk about, and they have kind of some slides on each of these bullet points, and just kind of the idea is to make it more conversational with Andrew and kind of go through, and we can we'll share our history and what's coming up in the future. So the first one is the history of analytical options. I originally had this in the cloud, but we'll go a little bit further back than that as well. And then open lakehouses and multi-engine. For those of you probably have heard of a lakehouse, but maybe not have heard the term multi-engine. So we'll kind of explain what that is and how exciting that is. Platforms versus feature companies. This is something I call it. It's my term. Andrew said he hasn't really heard it talked about this way, but I consider, back in the day, we just had platforms, and now we have what I call feature companies as well. They're all very, very good, but some fit, and how do they fit in? What is a platform versus a feature company? And then going to moving data versus federation. That's kind of an interesting topic to talk about as well. And then the future of AI. How is that going to help analytics? We see a lot of hype around that. And just kind of talk about what I think is going to be short-term and then possibly long-term, maybe a dream of mine. And then maybe Andrew can chime in with what he's thinking.
I can dream too. Yeah.
Yeah, exactly. So history of analytical options. Back when I started back in the day, we had Oracle as an OLTP system, and then we tried to kind of shoehorn Oracle into a enterprise data warehouse. That hardly ever worked. For smaller data, it worked. When we got to bigger data, it fell over. And then that's where Teradata kind of came in and filled the gap. And then from there, Netezza was born, Vertica, and then add probably 4 or 5 other analytical solutions there. I don't know if you remember this. I'm sure you remember this time, Andrew. Am I missing anything on there?
Oh, well, since I did a lot of work with Microsoft technology, I'd say you're missing SQL Server, but I'm just teasing. But no, I remember all of that really well. And I had a client a long time ago, big bank, and that they had Teradata. Those were in the early days, and I just remember the idea of getting your data on there, the idea of even having access to it. For development purposes and certainly for production purposes it was a very gated kind of thing, right? It was a very controlled resource. It was very expensive. It was cool because it could handle really large volumes of data, or what was then considered large volumes of data, really well and really quickly. But it just wasn't something where you went and did anything casual at all. It was really up on the top of a mountain. So it set a goal, but it wasn't a goal that I think a lot of people could execute on. And maybe I'm stepping on an intermediate punchline a little bit, but I think that's what gave so much momentum to Hadoop when Hadoop had momentum and big data. The idea was you should be able to handle even larger volumes of data, number one, and number two, you should be able to do it with kind of commodity everything and make it much more accessible and inclusive. I don't know what your thoughts were on that before we start getting to the next steps here.
I kind of had like a circle. I started with Teradata. And it was just a box in a data center, like a rack in a data center. I'm like, oh, that's cool. It must be some of this proprietary kind of thing they're doing. And then I got into Hadoop. And then, I used to own a data center, so I knew what Dell or R720s were and all that good stuff. And then I went to go work for Teradata. And probably one of my, kind of a depressing part in my career is when I actually learned that Teradata boxes were literally just Dell R720s with Mellanox switches. And I thought they were, I don't know, in my head, when you're a kid, you think something's different, then you get to there and you're like, oh, that was that's what my moment was, is literally just boxes there. And it was just Hadoop, but it was, there's Teradata software, but I thought it was some magical thing that happened. They were just ahead of their time. It was Hadoop on steroids, in my opinion. And then, yeah, when we got to Hadoop, that was another depressing part. It's like, this is great. Look at all these queries I'm running over this petabyte of data at this big telecom company. And then I found out that, okay, so there's no update statement. I'm like, oh my God, there's nothing. There's no reference integrity. Even if it was not enforced, there was no such thing. There was, I remember one of the top folks at Yahoo talked about, you could just add your data and then add structure to it later. And I was like, being a data warehouse person, I just like wanted to scream and plug my ears, because data, always has some kind of structure, and just throw data into this area Hadoop and just put structure on top of it later, turn into a complete disaster, which it did. So I think that's what happened, was we got away from what we originally had built up. And sure, people were making fun of it, how long it took to do a data warehouse, but then there was reasons why we put a lot of these controls in and stuff. And then that's why I brought up, like, here is like when we talk about into the cloud, and Redshift was really the pioneer. I think a lot of people really kind of talk about Snowflake, but I think Redshift was the first one to put, granted it was literally a pickup and put it into AWS.
It was a lift and shift in a way,
yeah,
but it was so easy to provision. You could go in there and within 10 minutes and 5 clicks, you could have it up and running. That was the first time I lived through that. I was just shocked.
Yep. And then the S3 became almost like, and it's still for a lot of companies, the raw or the staging layer. And then they would load that data into Redshift. And then I think I call it the new HDFS. I'm dealing with a lot of companies now that have done that. They've just landed data in S3, and it's become this big thing of data. And, they always move their data to like a Redshift or even a Snowflake or something like that. And then you look at what Snowflake has built. Was, I think a lot of people do forget. And I talked to a lot of customers about this, where they think Snowflake is this magic thing, and it's literally just EC2 instances, S3, and then, obviously SSD caching, and then to store the metadata is just in this NoSQL database. It's a key value pair called Foundation DB. So it's a little bit different kind of how Snowflake put that together, but it was all just technology that was at anybody's fingertips. They just had that point where they did it in the right time, and they put it together, and it worked. So the big difference, I think, with Snowflake compared to like Hadoop was Snowflake brought a whole bunch of people from SQL Server and a whole bunch of people from Oracle. And they took that same approach that I would take, is we still need to build, we still need to have all these controls, we still need to have people moving from an Oracle or Teradata come on to Snowflake and write the exact or very, very similar SQL and have basically the same kind of performance. Is that kind of what you saw too, Andrew? Why there's success?
Well, and let's remember, the founding CEO of Snowflake was Bob Muglia, who ran the server and tools business at Microsoft. That's where I knew him, because SQL Server and all the stuff I was using, all the Microsoft BI fell under him. So he left Microsoft, but I think he took a look at the market and he said, well, I see a lot of enthusiasm behind Hadoop, and I think a lot of that is economic, but Hadoop's not working, and we really need to bring people back to the more conventional, relational, dimensional world of a data warehouse. We just need to have at least the appearance of Hadoop economics. So it's kind of funny, right? If we had a bullet in the middle of the first two, it's like we went from a data warehouse infrastructure to a big data infrastructure. Then we went back to a data warehouse infrastructure with Redshift. Then we went kind of over to a data lake architecture with a lot of data in S3, mimicking the Hadoop distributed file system that was on premises. And then Snowflake brought us back to the warehouse. So it's this kind of shuttling back and forth, and it makes sense, because really what it is it's two forces, and eventually it's reaching an equilibrium. I think we're getting there now, but the two forces are, on the one hand, from the warehouse side, structure and data that's easily consumable and in a dimensional structure where you can analyze it readily, right? And then the more kind of open set of technologies that you can mix and match, but it breaks away. Structure's good, but sort of an imposition and too many constraints is bad. So we keep seeing a tug of war between those two, and I think what we're hitting is an equilibrium where we have enough structure on the one hand and a lot of freedom on the other. Oop, I'm losing you. Hold on.
Oops, sorry. No, that's me.
Okay.
Then we saw really the clouds looking at this, the quick success of Snowflake, and they benefited both ways, right? They knew they needed, they're still getting the money on the back end from Snowflake, but they wanted other solutions as well. So, you saw EMR pop up, which is MapReduce, and then Athena, BigQuery, Synapse, and some of these other ones that have popped up from each of the cloud providers to be able to, it's basically competitors to Snowflake, but using their same resources, just putting together the same thing that Snowflake did into a packaged up solution. So, and then I think BigQuery to me was one of the first ones. Athena was probably there before, but the idea of a cost per query, which I still is bizarre to me. Like if I'm in a company, how you ever budget that, because we've all been there, and people will run whatever queries they want to run at any time of day and run stuff that they shouldn't run. So the whole cost per query to me is still very foreign, but some people like it, especially in the smaller shops, especially for a startup, and you don't have a lot to pay for. You don't have a lot of money to pay for Snowflake.
It's not a huge upfront commitment. Yeah. And not only that, you don't have to worry too much about sizing things and provisioning things in an explicit way. It's not just that it's cost per query, it's that it's serverless in terms of resources. So I see the attraction on both sides. And actually, I think that'll be a theme as we further talk through stuff, is that things that look a little opposite sometimes are, they will appeal to different parties, and you may start with one and you may move over to the other because sometimes things are transitional. They help you on board, and then you look for a more mature way to do it afterwards.
Yep. And then that kind of gets into S3, 10 years later or 15 years later, I guess I should say, it's still hung around. They've really increased. I mean, even 5-6 years ago when I was using S3, it was fast, but not that fast compared to like a real spinning disk or real SSD. And then you look 5-6 years later, and it's unbelievable how fast they've made S3, ADLS on Azure and GCS, where we're getting very, very close to an SSD, and then be able to, especially in the analytics world where you are going over terabytes of data per query versus the old days where you're going through, like Teradata, we're just doing like a primary index query or a small amount of data, or maybe hundreds of millions at the most. Now we're doing, I remember I was in a client and they were running stuff all night, and we looked at some of the queries and they were over a petabyte in a single query. And that is insane to ever think about, even 10 years ago, that we would be at the spot where you'd have all these object stores with all these, basically they're SSDs together, right? People think that S3 is this magic storage. They're just SSDs, but they're distributed out, in a far way. So the big thing that I see is, can it deliver all the use cases? And obviously I think Snowflake's kind of proved that out, where that is the core of Snowflake. They are doing this. They've proven out to whatever 2 billion in revenue or whatever they have now. And I think that, and we'll get into this in the next slides coming up, is really into more of an open lakehouse with Apache Iceberg and Delta Lake. Where we're going with that is more of a, you own your own storage and you agree to use to put basically metadata on top of this, and you get to use whatever engine you want. So I think that's pretty exciting.
Absolutely.
Next thing I want to talk about was there's a.
Can I be the acronym, please, just in case there's people who don't know them? So S3 is actually, Amazon just calls it S3, but it used to be called Simple Storage Service. So that is Amazon's kind of canonical object storage. And then you mentioned ADLS, which is Azure Data Lake Storage on the Microsoft Azure side, and GCS, which is Google Cloud Storage. Essentially, those three things are equivalent, although ADLS was an evolution of the blob storage in Azure, specifically designed so that it could handle larger volumes of data, larger containers, larger files, and so forth, specifically driven by the workload needs for data and analytics.
And then most of those, especially S3, was never really designed for what it's being used for today with analytics. It was just more serving up websites and files that were there, or images that were there on a website. That was the original part of
It
the
was bulk
S3.
storage. Yeah, it wasn't
Yeah,
designed for query performance.
exactly.
Exactly.
And so they, people, the software had to change around that. It wasn't the other way around. It's not like S3 changed to HANA Analytics. Sure, they changed their speed and everything, but all the software around has built up to support something like an object store, which is much different than a file system, POSIX file system that we had like on Hadoop. So that's a big difference.
Yep.
So I wanted to quickly touch on this report from GigOn Research. I don't want to go into complete details of it, but just really the total cost of ownership that we're seeing a lot with something like Snowflake or like an EDW or data warehouse that's been in the cloud for years that we've talked about before is really, and we'll touch on this on the next slide, of getting back to this true separation of storage and compute and being able to land that data. The biggest thing that we've seen like with a cloud data warehouse is you still need to get that data into the warehouse. And we had the same problem back the day with Teradata, right? But if you can just land that data on like an S3, an object store, ADOS or GCS, and be able to query that within a second or two, that's the biggest thing that the advantage we've seen. Like I call it time to insights. That's the biggest thing. That's there's not much to complain about like a cloud data warehouse these days. Maybe cost, but we've also seen like the time to insights and then the duplication of data. So a lot of folks are landing that data on an object store like S3, and then they're moving that over. So now they're duplicating their data because it's like, well, this data is sitting in our cloud data warehouse, and we want to make sure we keep a copy of it just in case, right? And then we also have the multi-engine options where that's becoming, which we'll get into on the next slide, better cost control if you can use whatever engine you want. So like the last three are kind of like what we'll talk about next is the shift that we're seeing, and even Snowflake is supporting this with external Iceberg tables and stuff like that.
Right.
That's the big war that we're getting into.
And again, I think it's that tug of war, right? We want the structure, we want the performance, we want the paradigm of or interface of a warehouse, but we want the kind of commodity economics and the flexibility, and hopefully a lack of proprietary formats. And I think that's how we're getting to Lakehouse is, everything gets stored in some formats, the names of which you'll talk about in a little bit, that are open, but they have performance comparable to the proprietary formats that a lot of the data warehouse vendors have used.
Exactly. Yeah. So that kind of segues into, and I'll kind of go back and forth between this and a diagram I created, but open lakehouses and multi-engine. And this is something that, like, if you told me 20 years ago, like we could have, and I would be very, very excited about it, because I was in private sector for many, many years, companies, enterprise companies, and that type of stuff. And every place I went to, there was one thing we could use. It was either Oracle, Teradata, Informatica, or whatever it was. And there wasn't a lot of options out there. There was, there was ETL tools, but they weren't as good. There was always seemed to be like one leader out there. And you learn that, and that's how you build your career, right? I built my career off Informatica for 12 years, and it paid well, but there wasn't a lot of competition out there. And I think,
Right.
if you look at the separation of storage and compute, when I say that, is like with Hadoop, kind of got us halfway there, because Hadoop, you can add more boxes, but each box had storage in it. There wasn't really a way to add, let's say I was compute bound. My cluster is not enough CPU. I would order, call Dell or HP up, and I would order some more servers, but they came with storage because all the nodes in a Hadoop cluster should have the same storage. So that when I say halfway there, that actually got us to where we are separation, because you could have different kind of engines.
Oh, it's more modular. If you wanted to upgrade, you didn't have to trigger like the next tier with your data warehouse vendor. You could be more incremental, but you couldn't really scale the compute and the storage separately. You had to add a bunch of nodes. Even if you were adding them for storage, you were also adding compute, whether you wanted to or not.
Yeah. And I probably should have mentioned in here where the second bullet point, which doesn't exist in here, but the biggest thing that I saw in Hadoop and the most exciting was Orc and Parquet. I remember all of our files were CSV, I think, and then gzipped. And then I remember this gentleman, Jay Johnson, showed me one time. He was, watch this query, and it would finish in like, I don't know, a minute compared to like 3 hours. And we're like, how did you do that? Well, we use Orc. And I'm like, I thought he was talking about something out of, a TV show or something. And then he kind of showed me to him like, wow, this is going to change everything. And to me, that's the biggest. To me, I mean, Hadoop was cool, but I think just the columnar format in a file that actually had stats in it was like a mini database. And
And
to
I'm
me, that was
banging the
one of the,
same drum here, but like that was us going to open sort of the modern data platform on the one hand, but then we looked at the columnar storage that we had in warehouses that we didn't have in the open platform. And that's why ORC and Parquet made so much sense, because they were open formats that brought columnar storage back. And columnar storage is great for a couple of reasons. The first is when you're doing BI stuff, typically what you do is you want to look at only one or two columns and lots and lots and lots of rows, right? Because you're aggregating something, let's say sales. You don't want to have to skip over everything else just to aggregate that one column over zillions of rows. So if you store the column data in a more segregated way, then that scanning becomes a lot more efficient. What also happens is when you put all the data for a given column together, most of that data is going to be in the same order of magnitude. And that enables you to get high degrees of compression, which then makes the storage cheaper, whereas you still have the performance. So again, we kind of oscillate between, okay, we want to break away from that old style stuff, and then we realized there were some smart things about it that we lost, and let's see if we can bring that into the open stack, and that's what happened.
and I still have this presentation. I'll have to go find it one of these days, but I was explaining how Hadoop worked, and I had this library, and the library had whatever, like let's call it 100 rows of books. And what Hadoop got us to do is I had now 100 people to go down that aisle and look for these books that I'm looking for. So instead of having one person go down every aisle, I'd have 100 at a time. And that was awesome because it was like literally throwing hardware at it. We used to use that term in the background. And then we got to something where I worked at Databricks for a while, and I learned about Delta Lake. And I'm like, oh my gosh, this is like having a card. Was it the index cards, where I would go there first. I would ask the librarian, hey, where is this book at? And then they would say, okay, this type of book is in aisle 6, 10, and 12. So now I only need 3 people to go down those aisles and find the book for me. And that's where my introduction to something like Delta Lake, where you have metadata about, or index cards about the data that's out there that are now stored with the actual files. So they're stored alongside the files. And now you have basically a mini database that you can bring anywhere you want to. And that was my introduction to Delta. I was kind of blown away by the concept of it.
Plus, it's updatable. That was the silly thing with Hadoop's file system, is it was, the fancy word was immutable. But what that meant was you couldn't really update your data without completely rewriting the files. Delta kind of solves that by allowing us to write these small companion files, which we can do really quickly. And then those are the deltas, right? And Delta Lake engines can put those together and give you kind of the finished product, which is the base data plus all the updates, inserts, and deletes that came afterwards.
We used to have this term. It's still around, right? I'm sure you've heard of it. It's write once, read many. And that was the whole idea of a data warehouse, right? You were never really supposed to go update stuff, but of course you had dimension tables that you had to update. So I think when you look at the original plan from Google, right, when they wrote the paper, was it was made for web analytics. You never updating web analytics. You're just putting it in, and you're doing analysis on it, right? You're never like taking data that you had to update. And then all of a sudden the enterprise got a hold of Hadoop and they said, we need to update data. And we're like, okay, well, you can't do that. So it was taking a solution, but that, to me, I think it's a good history lesson where we got ourselves into. There was only a couple of different enterprise companies out there that are offering this, and they were almost, I hate to say the word hostage, they were holding a lot of company hostage. Like you couldn't move, you couldn't get out of some of these systems. And all of a sudden Hadoop came by, and they're like, oh, thank God, something. But people didn't really tell them all the limitations of it. And I remember people trying to do Tableau dashboards, that would take an hour, that would have taken, like less than a minute on their regular, their other MPP engine. But I think that was the biggest, but it got us halfway there though.
But that's how badly people wanted different economics, right? They were willing to kind of put up with a lot of compromises, but the technologies we have these days, the more modern ones, sort of say you don't actually have to make that choice. That's kind of what Iceberg and Delta Lake are about.
Yeah.
You can have an open format, and but you can still have the performance and the metadata, and hopefully pair that with a query engine that is very much like a data warehouse in terms of performance and engineering. And actually,
That brings us to this diagram.
that brings us to Starburst.
Yeah. Yeah.
Mm-hmm.
And I probably should put Delta Lake here because it's very, very similar, but I've been focused a lot on Iceberg in the last year. So I've been adding to this. There's like SageMaker now. There's probably another 5 or 6 engines out here. When I say engines, vendors, it could be open source, it could be proprietary. But I think like you'll see, and I think with Snowflake's driven to, support Iceberg tables that are external, I think it's been driven by their customers because they're saying, hey, we want to own the data in our storage, as you can see in this diagram. And I want all the cool stuff of the database, right? I want to read, write, alter, modify, partition, optimize, time travel, all the cool stuff I had in these databases. I want that. But then I want to be able to have everybody follow the same spec. That's why I put Iceberg API spec here. And this, you could say the same thing for Delta Lake, is I can pick and choose. I can hire and fire, as I like to say, or I can use multiple engines at the same time or these projects against my data. And that's the ultimate power of any kind of company, is when they have all these choices.
Exactly. And something I was saying with the customer yesterday when they were trying to understand the difference between a warehouse and a lake house, what I explained was that people with different specialties have their own favorite tools, right? And that they all want to bring their tools with them, not out of chauvinism, but really just out of comfort and familiarity and ultimately productivity. Everybody's going to be most productive in the tools that they know. The problem is, up until recently, if you wanted to use your own tools, you often had to have your own copy of the data. And what the open formats are all about is saying people can use their own tools and they can actually operate on the same data and work collaboratively, even though the interfaces, the APIs, the languages, and so forth that they're using may be different. But imagine if you're operational data people and your BI people and your more kind of open analytics folks and your data scientists were actually all working with the same data, not copies of the data, but the same physical data. That's, you look at it after the fact and you say, well, yeah, that's obvious. But the fact is we didn't have that, right? We only had it by going away and then coming back with a lot of integration and ETL work. And there's too much data to do that, number one. And number two, there is, and I don't mean to demonize it because I think it's needed, but there's too much regulation to do that. The idea of making lots and lots of copies of the same data, it isn't just inefficient, it's dangerous because you may be using old data, you may be using unauthoritative data, and you may be using sensitive data, and making copies of sensitive data is not good. And building machine learning models on data that's even like a tiny bit out of date is not good. So we're rationalizing things here, and yet we're still recognizing diversity. If I can be a little preachy there.
Yep, no, that's great. When we had first joined, I was telling Andrew about I was watching this little on Twitter on Larry Ellison, and he was talking, and I can imagine like 10, 12 years ago and going to Larry and say, hey, I'd like to take an Oracle database, and then I'd like to just push a button, and then I would like to just bring up SQL Server and point to the same data as my Oracle and everything should work fine. And he would just laugh at me. But that's where we're at right now. We're literally at a point where data is data, and we've all kind of agreed, right? There's Iceberg, there's Delta Lake out there. We'll figure out who's going to win that battle. But this is like the most powerful thing I've seen in my 25 plus years doing this, where everybody's kind of like, I think everybody's just done with the lock-in vendors. And I think everybody's been pretty careful. As long as everybody follows these different specs that are out there and plays nicely, I think it's going to be a battle royale, and you get to pick and choose. It's almost like your tool belt, and you have different tools out there, and you get to use whatever you want to. You're not just forced to use a single hammer for everything. So. And
again, I've been around Microsoft technology so long, but even within their own stack, they had all these different formats. Now they've introduced this thing called Fabric that is not just compatible with Delta Lake. It's basically changing the SQL Server based data warehouse and Power BI to be able to use Delta as native format.
Yeah.
Which again makes this reality possible, where everybody uses their own tools, they have their own paradigm, they have their own skill set, but they're actually working on the same underlying data.
Yeah, and we've seen this. This is the second last bullet point I have here and we've seen this a lot with Databricks over the last probably 10 months, is they've done, in my opinion, a very good job of what Delta Lake. They're open about their standards. This is what we're changing. Here's Delta Lake 3.0. They've just released something called a thrift meta store that we're now connecting to. So instead of hiding all that metadata behind a control plane that we can never get to, I give credit where credit's due, right? They're actually exposing all those tables and all the metadata for it. So now we can I guess you call it compete, right? Or we can use those tables and then we can work together. And they're, always not afraid of a fight, right? And I think that's the differences I have seen. Like that would never happen 5 years ago. We never have someone like Databricks, this big, large of a company, saying, "Hey, we're still open." We invite competitors to compete with us, and that's so weird to me to see, and it's refreshing, I think. So, I mean, what's your thoughts on that?
Well, of course, the founders of Databricks are the creators of Apache Spark. So and they all came out of academia, out of Berkeley. So they started with an open source kind of ethos and an open standard ethos, and it makes sense that they're remaining true to it. But although I do think they kind of veered away from that and they've come back. But I ultimately, to a certain level, supporting open standards is good business, right? Standards are powerful. Even bad standards are powerful, because if if everybody's using them, then you get a lot of efficiency as you kind of move across platforms and feature sets and so forth, right? And then you don't have to worry, you don't have to place a bet on this or that, because kind of everybody's adopting it. So I think it makes sense. Meanwhile, they are, innovating with their own technology in a proprietary way on top of that, but the foundation is still open and common. And it's funny too, because I remember when they briefed me on what's now Databricks SQL, and they were telling me why it was so much better than a warehouse, right? And then they went and told me about the Photon query engine. And as they were describing it, I said, "Well, you're telling me that warehouses are obsolete, but you just basically built a data warehouse query engine." And they said, "Well, that's one way of looking at it." But again, the difference is that the format is open and you're not holding the data hostage, which means other things can get to it. You can open a data frame in Python and operate on the same data that Photon is querying. And of course, that kind of open modular idea is what was always behind Presto and then Trino, which is the core of the Starburst platform.
Exactly. Yep. And that's what drew me to it, was the idea of a database with no storage. I was blown away by that, because there was always storage you had to drag along with you, and you had to worry about table space sizes and all this other stuff. And I'm like, wait, I just got to write query, and then it goes against all these different kind of source systems. So, and I think really what's next I had down here is I'm not sure. I mean, I think we had talked about this before, but I don't know who wins this Iceberg Delta Lake. I mean, the Iceberg made a kind of a big comeback late last year, where a lot of people, and a lot of it's competitiveness, right, with Snowflake and some of these other companies. But I think I'm not sure who's going to win there. I think everybody's going to benefit. I think the consumer and companies are going to benefit no matter what. I don't think it's going to be this big fight. We saw Uniform being announced by Databricks that will support Iceberg. We'll see what Snowflake does. This will be interesting. But I think in the end, I think whatever's going to come next, I think it's either going to be maybe a new format, or it's going to be just one that we're going to use for the next 4 to 5 years, and who knows what's going to happen from there. What's your thoughts on that?
Well, I mean, and this is not a universal analogy anymore, but once upon a time we had this way of recording television called a video cassette recorder, and there were two major competing formats there, beta and VHS. And You could use them side by side, basically, and eventually one of them won out. But ultimately, what happens, and you were talking about this when we were still kind of in the green room, as it were, right, is that each of the competing formats ends up picking up attributes of the other. And essentially, even if one wins out, it's because they effectively end up coming together. You're going to get the best of both in whatever ends up being, the victor. And I kind of agree with you that the customer is going to be okay no matter what. And using engines like Trino and therefore Starburst that can really talk to anything is a great way to kind of future proof yourself. So I think that's the way to go. Will there be new formats? Of course. No technology stands still. But if we can all have a consensus around today's format, then what we get with tomorrow's format will probably have a very clear migration path that is pretty painless. It's when everybody comes from something different, and we try and make all that shake out. That's where investments are at risk. But I don't think that's going to happen here because we're coalescing now finally.
Yep, and I saw this with Android too. I had an Android phone and I wanted to throw it out the window at the beginning because there was no battery life and they didn't do basic stuff the iPhone did. And then I think it kind of switched around where Android added all that stuff, right? And then they kind of forced Apple's hand on some stuff that they wouldn't allow or didn't have in their phone. And I think that's just competition. And I've seen this with Iceberg, where Iceberg added some stuff Delta Lake has, and then Delta Lake's added a bunch of stuff that Iceberg had. And that's what sometimes I think you're a little bit later to the game sometimes, and that's not a bad thing because you get to see whatever other people have done and maybe design a better mousetrap. I think that's what we're seeing a lot is like we have these two big behemoth companies out there with Databricks and Snowflake have blazed the trail, getting people to the cloud. And then I think now we're starting to see some companies out there doing some kind of like us, right? Starburst, some of the other ones that I see like a better mousetrap on stuff. And so, it's you to use one of these or stay with the platform that you have. So
I think there's examples all over the place of there being kind of a dichotomy that looks really severe that ends up kind of moderating. And, another one I just thought of is streaming versus linear cable, right? Because people are supposedly cutting the cord, but they're adding back services like YouTube TV, which is basically just cable over the internet. It's the same linear channels, but you're streaming it. So that makes sense. Now you don't need a cable box. You don't rely on a carrier to get your programming necessarily, but you still want the same kinds of content. The idea of a linear channel still makes sense. So it's not a perfect analogy. Most analogies aren't perfect, but things come together. Even, with Blu-ray, right? Blu-ray for watching movies on physical media, that's kind of going away. But that was a big fight. There were two formats there too. People don't remember there was one called HD DVD. This happens over and over again because nobody wants a monopoly. Everybody wants some amount of competition.
Yep.
And choice and some pressure on the vendors to innovate. But people don't want too much complexity either because it makes their time to value longer.
Yep.
So eventually
XML and JSON. There's a good one too.
Yeah.
XML is gonna be around forever. Then all of a sudden JSON came out of nowhere. So same kind of concept.
Well, everybody's keyboard with the less than greater than keys were starting to break, I guess, for XML.
Yeah. So. So next thing we want to talk about was platforms versus feature companies. So what do we define as a full platform versus a feature? The way I look at it was, and I should have put analytics in here. There's lots of different kind of platforms out there, but when I look at an analytic platform, is more than just a database. The ingestion part of things, the governance, so all the security that's built in to it as well, and then being able to serve that data up through just SQL queries or Python or any of that kind of stuff, and then machine learning, all those kind of things. I actually have a diagram here. There we go. Yeah. And this is just me typing. There's a bunch of stuff out there that you can probably add to this. There's reverse ETL and all this stuff. But when I look at like a basic analytic platform is how do you ingest the data? How do you transform that data and add to it? And then join to it. And then how do you roll that data up and aggregate it and share it? And then also at the bottom, you kind of have these that we've drawn this boxes forever, right? Data governance means a whole bunch of different kind of things. Orchestration, how do you get things to run? And then, which is I mean, that could be a whole webinar just talking about the whole collapse of a scheduling tool like that. Of my career, nobody has nailed that. And if they do nail it, they get bought by some big company and it turns into a $350,000 buy. And then all the innovation goes out and then you get stuck with something called Airflow. So, and then you have ML, AI, app serving and all that stuff down here. So this is kind of like when I say a platform is something that can serve a lot of this stuff. What are your thoughts around that?
Yeah, I'm looking here too, because I'm getting obsessed with this sort of tug of war that turns into a consensus. But on the one hand, people want flexibility and they want modularity. On the other hand, they need things to be kind of turnkey and easy to consume. So I'm looking at and this is not a novel model, right? This is something that was introduced a while back, but this medallion architecture and the difference between silver and gold is kind of there, right? And that was, if you push those two further apart, that's kind of where we had lake and warehouse, right? So there's always going to be needs to do exploratory stuff and look at the unknowns, right? And then the ability to do more operational, still analytical, but operational analysis where you kind of know the questions, they're known unknowns, and you want to have structures that are optimized to answer those questions really, really quickly. And, that was true when we had relational OLTP, and then we had warehouse, and then we had OLEP cubes, right?
Yeah.
Ultimately, it's like more and more restricted, but also more and more optimized for performance. But those were still very separate islands, and this is much more what we have here with the medallion structure is a much more cooperative kind of flowing, dovetailing and compatible spectrum of approaches that all fit together.
Yep, definitely. And then, when I look at a feature company these days, I think is much different than 5-6 years ago. And that usually required moving data out of a system and then storing it. And that was much tougher to sell. And I think when I look at a feature company today is we're in such an open environment where, you can point somebody to an S3 bucket and then they provide analytics for you. They pull that data out and they return back to analytics, or they provide dashboards for you. I think that's a big difference between that I've seen in the last 5-6 years where companies are sprouting up to solve something. It's either in, vertically, for healthcare or whatever it is. And they're providing a service basically. Even look at the reverse ETL. Like I first learned of that term and I just started laughing because we did that forever, right? We would send data back to something, but then somebody came up with the idea of it. And now it's just a quicker way of doing it. We always had a hard time sending data. We'd have to get an SFTP login or something like that. And now that's become so easy. And then feeding that data back into these APIs and these sources like Salesforce and that kind of stuff. That's kind of I look at that as a feature as well, but a successful feature. So, and then really, what is the history of feature companies? So acquisition. So I meant to say future. I should have saw that, but what I meant was by future. So some of these companies have really popped up in the last 4 or 5 years where they're providing one service and it's done very, very well. And then you're starting to see the platforms start to, create that themselves. And so you're starting to either see them go away or you're starting to see them either get acquired. And I just want to get your thoughts on that. What do you think about it? Because there's that's what's great about this country. There's always entrepreneurs working on something. So,
and it's not just this country, the United States, right? It's lots of economies. But what was I going to say? Yeah, I think of self-service data prep as a good example of what you just talked about, which was that there were multiple companies doing this. It's all they were doing, but it kind of looked like it should be a capability that lots of platforms had, be they analytics platforms or AI platforms. And lo and behold, that's kind of the case today. And most of those companies got acquired. Most of those data prep companies got acquired by analytics or AI companies. But what usually happens is we take a problem and we break it out separately with separate companies that get their venture funding and really innovate and really perfect. And then it kind of comes back to the more core stack. I don't know if that's the most efficient way to have innovation, but it, it is what it is. The problem is that if you get companies that are too monolithic with too big a stack, they lose the motivation and really the competitive need to keep innovating. So that's why smaller companies get funded, do something that kind of breaks up the monopoly or the duopoly or the triopoly. They do some interesting stuff, and that's how we de-ossify the tech. Is
Yep.
instead of just having owners, we have champions and challengers, and that's typically a good model.
Yep. A company I was introduced a little bit ago, it's called NetSpring, and it was very, very interesting. Something you could never do 5, 6, 7 years ago. NetSpring actually works on the data like in your Snowflake environment. So you get a UI, you give it the login, it brings our tables back. Granted, it's a specific use case for like product analytics, but I thought that was a new wave of product companies to me that just are working on top of it. It's almost like hiring a consulting company to come in and work on your data, but it's actually software. Instead of moving the data out and creating this product analytics data warehouse and then putting reports on it, they're actually creating tables and doing stuff within your environment. I thought that was the most interesting thing I've seen that's just one vertical that they're doing. Imagine all the different verticals out there that you can now create companies that are almost like consulting companies, because the majority of the data is kind of the same. But if you did that mapping, almost like an Informatica mapping, if you map that up, push a button, all of a sudden, now you have analytics based upon supply chain or something like that. I thought that was a very, very interesting idea.
I think it's normal for custom solutions to emerge, and by the time you have a critical mass of companies or customers doing similar custom solutions, it shouldn't be custom anymore, right? There should be some platform with common engineering efforts going into it, so that people can then that becomes part of what you start out with instead of something you have to build. And yeah, that happens in industry verticals all the time too. So there's always going to be the time where something you need is not available off the shelf, and then if enough people kind of want it and prove out that there's a market, then it becomes available. Not off the shelf these days, but in the cloud.
Yep, definitely. Okay, so next I want to talk about was the future of AI. And if you, for those of you listening, have any questions, I know we had a couple of questions come in, so we'll address those. We'll leave a couple minutes here at the end to address those questions. So the future of AI. So this is the big hot thing right now. I was in Colorado a month and a half ago. Had lunch with my friend Amy, and she's working at a company. She's director of analytics, and I think it was her CTO came in the other day, and he's like, "This is going to change everything. We need to do this, this, this." And she's like, "I just need basic help with the basic things, right? It's the blocking and tackling. I need to get data in and then report on it. All this other stuff you're talking about is great, but that's not going to help me with my day-to-day stuff." And the way I see this playing out right now, it's like we've been playing around with this with Starburst. We actually have it working where you just type in something, right, and it creates SQL for you. That's like, to me, the lowest hanging fruit is how can I make my job right now faster? I just need to ask a question instead of me translating that in my head to what the SQL is going to be. Is I need to write this out. And the next thing that I wasn't there, unfortunately, but there was a Gartner conference in Florida a couple months ago where they did this. They just said, create me a sales dashboard or whatever it was. And while the guy's talking, I guess in the background, it created a whole Tableau dashboard. And they're like, that would take 4 months to do. That was the second thing. And then this data pipeline generation is I have this data in the source system and I need it to do this. I needed to create some data marts out of it to be able to do sales projections per quarter, per year, whatever it is. And I do that. And then it goes and builds all that. To me, it's the lowest hanging fruit. What are your thoughts on that?
Yeah, well, I mean, the second L in LLM, large language models, is language, right? So LLM's most mainstream applications involve generating English or other spoken languages, but like GitHub Copilot can generate code in various languages. Generating code in SQL makes sense. As far as reports go, there's markup languages for reports. So why can't LLMs be used to generate that? And likewise, a lot of the pipelines these days are either in a markup language or they're actually in some specialized dialect of SQL. So yes, this is the low-hanging fruit. I would say we've only really scratched the surface of what LLMs can do, and most vendors have achieved parity with each other in terms of saying, okay, we're going to have a natural language interface to queries. Is often the most common, but you've outlined a couple of others here. But LLMs can even be applied to things that don't have to do with language. Um, I would I mean, you mentioned full data lake building and serving. I think I could definitely see that. To me, the next frontier is governance and the ability to get um, uh, data catalog and various things around that, the permissioning, the role based stuff, the attribute based stuff. There's a ton of manual work involved in that. There's a ton of manual work involved in getting data cleansed and getting data quality up. And it would make a lot of sense if we could use AI to get us to 90% of the way there, and then we use humans to get us from 90 to 100 to go the last mile. Right now, we're too reliant on humans, to do the grunt work to get us from 0 to 90. And so a lot of companies don't do it or don't do it well. It's too expensive and it's too risk laden and it's scary. And I think that holds people back from being really data driven companies. And I do think AI can be harnessed for that. I don't think that's happening yet. Tom, we're not hearing you, or at least I'm not.
Yep. So some people, like the younger generation, they're kind of working in these startup companies and that type of stuff, and they see they can use a lot of this. I just laughed the other day. I live out here in New Hampshire, and I have propane out here, and there's a company called Irving, and that's who we use to fill up our propane, and they have no idea when I have no propane, so I have to call them, or they just come by randomly, and I see them stop at my house, then they'll go somewhere else instead of like going up the street that I know like 15 other companies. My neighbors have Irving. So finally, the other day, they came by and they're in my rear. And I'm like, hey, what are you guys doing? We're putting a little antenna here. I'm like, it took you this long to be able to. I mean, this is a huge company. And it just shows you that it's that blocking and tackling. And if you look at this SQL generation, if you're not structuring things the right way, or using maybe common terms, this is the customer table, this is this. If you're doing stuff the right way in the first place, if you build that base up the right way in the first place, you could take advantage of some of these cool technologies out there, because you got your house in order to begin with in the first place. Now Irving could probably do some really cool stuff with this analytics. Let's see if they do or not, right? But that's the tip. People think that these huge companies are completely innovative, and they're not really, right? It's just really the low hanging fruit, the blocking, tackling that people still have a hard time with. And then I had this little part here at the end, was like the dream to me was, they're using a lot of AI on front end systems, but imagine feeding that data back and then making decisions based upon analytics in real time, and be able to adjust the behavior or whatever it is on the front end systems based upon that. So you can do it on a per system, but if you can pull in data from 1,100 point of sale systems throughout the day and look at these decisions, what's going on here, maybe you can actually use AI to be able to modify the behavior of each of these point of sale systems to do something different, to pitch something else or something like that. That's where I can see like the next version in the analytics world, to be able to assist. I'm not really getting rid of people and that kind of stuff. Do something that we've never been able to do before. I think that's the exciting part for me. So
Yeah, I guess we need to think of the fact that, a lot of things that we do repeatedly and manually, we could do on a more automated basis if we measure things and collect certain data. And if we could learn how to express these things that we do by feel in terms of formulas or in terms of procedures, and the AI really helps with that. It's not actually magic. It's just much more granular observation and observation of the data, and also observation of the patterns of what it is we do with that data, that kind of determines it may determine that something can be algorithmic even when we don't realize that, or you maybe don't even believe it. But a lot of stuff we do is repetitive, and computers are great at repetitive tasks.
Yep.
And I think AI, and especially generative AI, is good at automating things that we didn't necessarily realize could be automated because we didn't see what the procedure or the algorithm in it was. And AI is helping with that.
Yeah, even just going through a SQL audit logs, and saying, what is our common SQL? What kind of questions are people constantly asking? Maybe I can help them out. Just stuff that a lot of companies don't have the people power to do it. And I think that's the way I look at AI, is being able to do some of the stuff that, granted the SQL generation, but some of the stuff that we never had budget for, that can actually do it at a fraction of the cost, that can say, okay, we need to actually go create these 20 data marts because these questions are being asked for it all the time, and go do that for me. And that's where I see an advantage of it. So I don't see it really replacing all these people. I see it definitely augmenting what we couldn't do before. So
I think it's a cycle of putting more capabilities in the platform, but platforms are called platforms for a reason, because you build on top of them. And there's always going to be more we can build on top. But if the platform raises, then the things we build can do bigger things.
Yep,
maybe I'm naive or an overly optimistic person, but that's how I see the AI working out, is that it will enable us to just go a level higher.
Yep, I agree. We had one question I wanted to cover real quick, was it's more of a vendor type of a question on how does Snowflake and Starburst compare in terms of performance, and then how do open source Apache, Iceberg, and Delta Lake compare to being deployed? I'll do the Iceberg and Delta Lake one first. The way you look at it, I think people get confused a lot, especially the customers I talk to. They think like Iceberg and Delta Lake are actually products from open source. They're literally, there's code in there, but there's really, think of a specification that everybody's going to follow, or like building plans for a house, and we're all following the same plans. And sometimes we get either a company doesn't implement all those things in the spec because they don't have time or something like that. But most of the time is if everybody's following that same spec, then there isn't really a big difference between Delta Lake and Iceberg. It's just different ways of doing things. They're pretty close to what they do. It's still metadata on top of files. But usually, I think that's
usually Parquet files. So yeah,
exactly. Yeah. That's kind of like that. We just made that big switch in Trino, I think last month, is to, we would default to org, and now we default to Parquet. So Parquet won that battle. We'll see what happens with the other two. And then as far as Snowflake and Starburst, I don't think there's a lot of difference, in my opinion, lately. I know I work for Starburst, but I wouldn't be here if I didn't believe in it. I think Snowflake is absolutely terrific software. They're innovating with marketplace and all the other stuff, but when it comes down to core performance, I don't see a lot of difference, not only just Starburst for Trino, but other engines that are out there. I think we've hit a spot where there's only so much things you could do with SSD caching and that kind of stuff. Is you still need to get that data from S3. There's a big announcement coming out, I guess, next month at reInvent about some kind of new S3 that's going to be super fast, but who knows? They'll probably charge a bunch of money for it. But I think we've hit that wall, in my opinion. On there's some tricks you can do. There's definitely engineering. We have an entire performance team working on this, so I think that'll never end. But as far as these major gains in performance, as far as S3, EC2 SSDs, I think we're at this. It's almost like the CPU. Like we've hit that wall with the gigahertz, and now you're just trying to figure out different ways of doing it.
So you're saying that, the Moore's law of data analytics is sunsetting. Yeah, I agree. The competition's always going to be there. I think the major difference with there's huge power in a standard, right? And we've been talking about that with respect to Iceberg and Delta Lake and other examples. I think what's interesting about Trino and Starburst is that you can work with multiple standards. And because, in a perfect world, we're all using one. In a real world, there's a diversity. Snowflake really demands everything to be in there right now, proprietary format. Soon it'll work with Iceberg. Starburst is, let's say, more agnostic about formats. Probably you're pretty opinionated on kind of what an optimal format is, but you're also super flexible on what all the sources can be, and minimizing the amount of work required to get everything to work together. So I think
we're mostly
that's the big
Switzerland.
difference. Yeah.
I like to say we're Switzerland. We try to be. So, all right. Well, I think we're out of time. I appreciate the conversation, Andrew. I appreciate you joining, and hope everybody learned a lot. And if you have any more questions, you can contact one of us. Definitely.
Absolutely. Thanks so much. This was
All
great.
right.